Good morning, class. So in this short video we are going to learn about a physical phenomena known as diffraction or diffraction. So if you have ever wondered that, suppose this is a light source, and if I put my hand in front of the light source, I am completely able to block the light, right? You are not seeing light, but no matter how close I put my hand to my mouth, you are always able to hear me. So why is it that my hands are able to block the light wave but not the sound wave? So the reason lies in diffraction. So what happens whenever a wave is traveling and it undergoes an obstacle? In that case, the light is not able to reach, or the wave is not able to reach the other side. As a result, on the other side, it forms a shadow. Now, when the wavelength of light is of the same order as that of the obstacle, like in the case of the sound wave, the wavelength lies between 17 millimeter to 17 meter, right? And you know that my hands are in the same dimension, right? So in that case, the obstacle is of the same order as that of the wavelength, and hence in this case what happens, that wave is able to bend and reach the region which would otherwise lie in the shadow. Okay, but in the case of light, the wavelength is somewhere between 450 nanometer to 700 nanometer, and hence 450 to 700 is very small, about 0.5 micron. So what happens, the order of magnitude here is in centimeters, right? So that's why you are not able to see the light, and in the case of sound you are able to hear it. We are going to see a small demonstration where this has been shown for waves on the surface of a water by University of New South Wales, Sydney, Australia. So let us go to the animation. Here you can see that there is a bar which is being set into vibration by some mechanical means, okay, and that is giving rise to the wavelength, that is giving rise to the waves on the surface of the water. These waves are kind of parallel waves, okay, and they travel in the water, and they are made to face an obstacle which is shown here, okay. So next we will see whatever is the waves that is being recorded here through a mirror. So these waves are projected onto the mirror, okay, and then this mirror projects them onto a screen here which is being recorded. So here you can see the waves are coming from this direction, and when the wavelength is short, that means short as compared to the dimensions of this uh, prop, of this obstacle. In that case, you are able to see that there is this region, okay, from here to here, where there are no waves, okay. So this kind of forms a shadow. But when the wavelength is long, that means wavelength is comparable to the obstacle. In that case, you see that even in the region which was previously in shadow, there are waves. So basically, these waves has bent over the obstacle and reached in the region which was previously in the shadow. And this phenomenon is known as diffraction of light. I hope that clarifies the concept. Thank you for your time.